Hello and welcome to this video where we're going to go over some concepts regarding the range and the interquartile range. For those that don't know me, my name is Timoteo. I'm a mathematics teacher and I'm doing this series of video on how to prepare the mathematics A levels, which I'm complementing with my webpage that you can access the link via the description. The idea is that we get to cover the essential things via this YouTube videos. And well, I'm complementing explanations and exercises in the webpage as well. So to begin with, I'm going to go over the concept of range before we address the interquartile range. That is the grand topic for this video. The range is something very simple to understand. It's just we are going to take the difference between the largest and the smallest value. And as we were doing earlier, we're going to focus on both advantages and disadvantages. In this case, the advantage is that it's very easy to calculate. It's just a subtraction. And the greatest disadvantage is that it doesn't take central values into account. It just considers the extreme ones. So essentially, it's, as I was telling you, it's very easy to calculate. I want to focus on one important thing that we may find when talking about the range, that is when we have rounded values, then we could eventually have more than one range. I'm going to see why. So imagine the following case. We have given to the nearest centimeter, the tallest and the shortest pupils in a class are 169 centimeters and 150 centimeters. And then we are told to find the least and the greatest possible range. Why is that? Well, that is because this height of the student that we have here, for example, let's consider this one here, 169 centimeters. This height that was 169 centimeters, as it was given to the nearest centimeter, it was rounded. If you don't remember much about rounding, you can check the materials on histograms, both the webpage and the YouTube video, because I have explained that in depth. But the idea is quite simple, is that, okay, the height is not necessarily exactly 169, because he could be 168 and a half. And as we round it, the value would be 169. So the height is between this value and 169 and a half, not including, right? Because if the height were 169.5 exactly or more, then the height would be rounded to 170. So these are like the values for the possible height considering the tallest pupil. Same thing would happen with 150 centimeters. The height would actually be between 149 and a half, including up to, but not including 150.5. Because again, these are the range of values that will be rounded to 150. So as these are the values that could be rounded to 150, then we can have two possible ranges. You can have many possible ranges, right? You can say, okay, 169 minus 150, and that's it. You get 19. But you can have the greatest, let's say, range that will be the greatest value that we can make with these numbers. It will be 169.5 minus 149.5. We take the upper boundary for the highest pupil and the lowest boundary for the shortest pupil, and then this will give us 20 centimeters. And then for the least range, the least possible range, this will be 168.5 minus 150.5. We're taking the lower limit for the tallest student and the upper limit for the shortest student, and this will give us 18 centimeters. So from there, we can say, okay, well, we don't know exactly what's the difference between the tallest and the shortest pupil, but we know that it is at least 18 centimeters. It cannot be less than that. and is at most 20 centimeters. It cannot be more than that. So this is what we're doing here with this range. We're considering like, okay, we're giving these boundaries to the range. Next, we're going to move on to now, yes, the key concept for a video, that are quartiles. And quartiles are values that divide the data set into 4 parts, thus quartile. We have already discussed 4 measures of central tendency. The median. The median divides the distribution into 2 equal parts. So as you see here, the median will also appear as a quartile. The median is also a quartile. It is both a measure of central tendency as it is of position. So here what we have is that the lower quartile, that is Q1, is the one that accumulates up to 25% of the data sets. It's the first quartile of the data, first quarter part of the data. Then the median accumulates up to 50%, and the upper quartile, Q3, accumulates up to 75% of the data sets. And from there, we're going to define the interquartile range. That the interquartile range is calculated as the difference between the quartile 3 and the quartile 1. So if this were our set of data, we will have the range to be all here from largest to smallest value, but the interquartile range would go from Q1 up to Q3, will be a much more central range of data. How do we find it? Well, we need to consider if we have an even number of values or an odd number of values. If numbers are even, we're going to split the data into 2 halves, the lower and the upper half, and then we're going to take the median of each half. The median of the lower half is quartile 1, and the median of the upper half is quartile 3. Plain and simple. If we have an odd number of values, well, we're going to be doing the same thing, just that we're going to discard the median when we make the analysis. It's like we're going to consider all values, and then we're going to find the median, we're going to discard it. So that we're going to have 2 halves of equal number of values. Let's take a look at some examples so that we can see it more clearly. We have here this set of the values that are already ordered for you, that are 2. I'm going to write them down here. We have 2, 5, 9, 13, 29, 33, 49, and 55. As we have the number of eight values, an 8 number, we can split this into halves, and we can say, okay, these 4 values are going to be my lower half, and then these 4 values that we have here are going to be my upper half. And that's what we want to find is we want to find the median for these 2 sets of data. Now, we don't care about the median of the 8 values. We just care about the median of 4 and 4 because we're looking for the interquartile range. So for this lower half, we will take the 2 central values that are 5 and 9. We would add them up and divide over 2. That will give us 7. So this 7 is our quartile 1. And then for the second one, we're going to take again the 2 central values, 33 and 49. We will divide this over 2, and this operation will give you 41. And this will be our quartile 3. So then, how is it that we can find the interquartile range? Well, the interquartile range is simply and straightforward. 41 minus 7, this gives you 34, and this is the value for the interquartile range, 34. And just that's like the difference that we will have between the quartile 1 and quartile 3 for this set of data. Another example now, yes, with an odd number of values, so that we can see this that I was telling you about the discarding. We first need to order these in ascending order. So we will take first the 6, then we will have the 17, then the 39, 43, 69. Sorry about that, 69. There. Then we will have a 73 and a 77. So again, we're going to find the median. This here is the median, so we're not going to use it. Thus, we have 2 sets of 3 values each. Again, lower half and upper half. three values each. Here we can see that we have three ordered values. So the one in the middle is the median. So this 17 is going to be quartile 1. And then this 73 is going to be our quartile 3. So then again, the interquartile range is just 73 minus 17. This gives you 56. And thus, that is the value for the interquartile range, just 56. In this case, it was easier because we had the values, we would just find them directly. We didn't need to make any average, but it's just that. Another thing that we're going to be combining a lot are both the interquartile range and the quartiles with the stem and leaf diagrams. Stem and leaf diagrams can be used when working with this because they already give you the data ordered ascendingly. So it's easier for you to process it. So, for example, let's look at this. We have this stem and leaf diagram that has 13 grouped values. For example, the key here tells you that 14 and 2 means 142. We're not given exactly what they mean, but they are values that we're going to be using, and we're going to find again the interquartile range. So we have 13 grouped values. So the median is at position 7. Right? The idea is that again, if we're given the information for the amount of group, the median is a position n plus 1/2, so it's the same position. So then we count. We go here and we say, okay, 1, 2, 3, 4, 5, 6, 7. That 7 that we have there is the median. I'm going to mark it here. This here is the median. So we will have then two sets of data. We have this upper half. I'm going to mark it here. It will start from here up to here. Will be of 6 values, right? You have 5 here and then this one. And then the upper half that we'll have here and there, lower half and upper half. And then we need to take the median of both scenarios. And again, the median, in this case, I would have 6 values, going to be at position 6.5. 3.5, because it's 6 plus 1/2, 3.5. So we need to take the average of these two, for example. For the lower quartile, it would be 144 plus 148/2, and that would be 146. And there we will have the this would be our quartile 1 because it's the median for the lower half. Then for the upper half, again, same thing. We're going to say 1, 2, 3, 1, 2, 3. The median is going to be here. So we're going to say 157 plus 159/2. This will give us 158, and this would be our quartile 3. So from there, we're just going to say, okay, so that means that the interquartile range is going to be 158 minus 146. That this gives us 12. So there we have the interquartile range for these sets of values. Again, as usual, if you want to look at this more in depth, you can go to my webpage. You will find these examples and more for you to practice. Finally, the last thing we're going to be doing is we're going to expand ourselves into percentiles, and especially we're going to work with community frequency graphs. This is again quite straightforward. Here we're expanding the idea on this quartile into a percentile, and here is that we are accumulating up to the n% that we are given. So for example, the 10th percentile accumulates up to the 10%. The 25th percentile accumulates up to 25%. That is the quartile 1. So from there we can get the idea. So in general, if we are given a data from the total frequency, we can look for the percentile at the n times the frequency value, where we are expressing n in the decimal form. It's quite simple once you look at examples. So let's take a look at this. We have a graph that illustrates times taken in minutes by 500 people to complete a task. So the cumulative frequency is 500. So let's see, first of all, if we can figure out the greatest possible range. We're going to take a look at the graph here. I'm going to zoom in a bit, and we're going to try to see the what looks like our greatest and our lowest value. We can all see that the greatest value is around here. Here, this point at the top, that will correspond to 30 minutes. That will be the maximum. And then the other thing that we can look at is what will be the smallest value that we find. So if we look at the, sorry, I don't know what happened there. There you go. If we look at the graph and we focus on the smallest value that we can find, we should see that this is from 0 to 5. So each mark corresponds to half a minute. So then the smallest value that will be here would be 2 minutes. So from there, the greatest possible value, the greatest possible range that we can find would be the difference between these two, would be the difference between 30 and 2. That would be just the greatest possible range would be 30 minus 2. That will be 48 minutes. So the difference between these values, would the greatest difference that we can find is 29 minutes. Now let's focus on the interquartile range. The interquartile range, as we know it, is the difference of Q1 and Q3 and Q1. So we should focus on how to make that appear. And the idea is that, remember that quartile 1 accumulates up to 21%. So its position is going to be found at 500 times 0.25, because we have 500 people and we're looking for the 25 to the 25% of that. So we take this would be equal to 125. So we need to focus on where on this graph we can find the 125. Let's go and zoom in again so that we can look at the graph more clearly. And 125, this would be 150. So we have 10 by 10 is 20, 25 would be somewhat around here. So then we go and we take this down a bit. And we will be around, let's say that we said that there were one mark, this is 6, 7, and this will be 8 minutes. That will be our quartile 1, right? Because this is where we are marking the value there. So we're going to write it over here that the quartile 1 is 8. And then for quartile 3, again, very same thing. For quartile 3, we know that we're accumulating up to 75%. So we need to take the 500 and multiply times 0.75. This would give us 375. And from there, again, we're going to look for that value in the graph, in the cumulative frequency axis. So we go and take 375. This will be 90, 80, so it will be somewhat around here. So we go over here and we will find the value around there. And so from there, I'm going to draw now, yes, the line. And this looks something like 14. So I believe that it's safe to assume that this difference, that this value is approximately 14. It may not be exactly 14, it could be 14 and a half, equal to 14. So now, again, the interquartile range is essentially just going and doing well. We're going to take here, the interquartile range is 14 minus 8. That gives you 6 minutes. So that we can make like a more central analysis on the range that we were given earlier. That is, okay, the maximum range is 28. Well, the interquartile range is just 6 minutes. So We can talk about a central this we go to so a central tendency of people here. This will be like the 50% of people like more centrally that took with 6 minutes of difference of time to do the task. That's something to analyze. And then finally, 95th percentile. The 95th percentile, you can find it by taking the frequency, 500, multiply this times 0.95. So from there, we can see the value that we're looking for. We're looking for 475, and we take that into the graph. So again, we go to the graph, we look for 475. That is going to be somewhat around here. This would be 75 around here. So we project this line over here. And then we're going to take that down up to, I wanted to draw it with the lines. Here it is. Line, it would be somewhat around here. So that would be 24 minutes. Okay, that's like the best we can do with this graph that we have here. Approximately 24 minutes will be a very reasonable prediction to make. So this is everything that's on interquartile range and quartiles. If you have any questions, please use the comment section. Take a look at the other examples in the webpage as well, and keep on practicing with this. It's not hard to follow once you get the idea around it, but you may need to take some time to practice. In the following video, we're going to go over the concept of variation and standard deviation. So take a look at that video as well, and well, thank you for watching as usual.